Why is the whole always more than the sum of its parts? Burkhard Heim has formalized this well-known or almost trivial saying in his Centrometry. In doing so, he does not necessarily solve the problem of why that is so, but he certainly does give us a great help in how to handle this and how to make distinctions. In this video, I want to give you some more theoretical background to Centrometry and then dive again into colorful examples. Hello and welcome to 6 Dimensions in Color. My name is Schmid and I explain to you Burkhard Heim's worldview in understandable language and with clear examples. In the last video I gave you this structure of the physical world according to Burkhard Heim, where we could distinguish between different intellectual levels, the so-called totalities. And this whole thing was a kind of, can be regarded as a kind of scale for the dimension x5, the fifth dimension. And we went from totality 0 to totality 6, or even to pseudo 7, which was an anthropogenic bonus. And now I still owe you an explanation of what a totality actually is. For all newcomers to Burkhard Heim, the German physicist without hands, hearing or eyesight, in this playlist I am giving the complete introduction to all the topics that lead up to today's video's topic. And before I start, kind greetings to all my awesome Patreon supporters. We had the example of English language structured in such a way that we have at the basis we have word stems, from that we have conjugate forms and composite words, simple sentences and complex sentence constructs. These word stems, they act as the primal elements of my language. You could say I cannot reduce the English language, I cannot reduce the language any further without leaving the area of English. As you may know, Burkhard Heim created quite some language of its own, and I want to introduce some terms here. The elements that are at the basis, he called the apodictic elements, those that are set in the beginning, literally. And the set of them he called the metrophor, the carrier of measure. So all these elementary forms and word stems, they are the measure of English language. Then we have laws that make composites from these basic elements. We have one law that uses the elements of the metrophor to form a first syndrome, he called it. Syndrome is nothing bad in this context, it simply means a convergence. Yet another set of laws induces a second syndrome from the elements of the first syndrome, and so on. And for these laws, Heim also formed a new word. It's a syndrome level correlation inductor, or short, a synculator, or synculation law. Here I have another general overview over the concept of the syntrix. So I have the metrophor containing the apodictic elements. I have synculation law inducing the first syndrome, second synculation law inducing the second syndrome, and so on. Above any metrophor, I can in general induce an infinite number of syndromes. So now I can build a very, very large number of sentences with using the, or also not small, but much smaller number of apodictic elements. And this whole thing that describes the English language, that's called a totality. But what now if I want to create not just sentences, but a meaningful piece of literature? Can I just say, I use another synculation law? Well, we must always keep in mind, this was the logical area of the English grammar. And I cannot value grammar so highly as to assign it the ability to induce meaningful literature. No, if I want to form a meaningful text with an intention behind, I'm leaving the area of grammar and go to a new, well, it is a new totality. And that one I call literature. And this new totality, the highest elements formed by the totality below, my composite sentences, become the apodictic elements of a new metrophor. And then, above this new metrophor, I have new synculation laws which concern things like expression of emotions, character description, poetry or truth. That's precisely the reason why in your school essays you always got two notes, one for grammar and one for content. At least it was like that in the German school I went to. So the elements of this new metaphor of the totality above, they are actually syntaxes themselves. And to generalize the whole concept of syntaxes, Heim called this a metaphoric complex, or short a Metroplex. If the apodictic elements of one metaphor are syntaxes or metroplexes themselves, then these syntaxes are called syntropodes because they are like standing in the totality below. And you can easily imagine that you can do this for an infinite number of levels, and you have a whole Metroplex construct. And you can assign levels, of course, and the only true syntax, so to say, you could call a Metroplex of grade 0. And with this theory behind us, we want to go back into the realm of physical science, of technical science. Let us look at chemistry now. If you remember the last video, the chemical elements, they are the elements of our periodic table, and they were located on the totality number 4. And the totality of molecules, that of where the laws of chemical bonding prevail, that's totality 5. So the apodictic elements of the metaphor of totality 5 are elements of totality 4, which are my elements of the periodic table. But we just look today at carbon, hydrogen and oxygen because we're doing organic chemistry here. So from these apodictic elements, I form water and pure carbon. It's completely feasible to transpose an element of the metaphor non-changed into the first syndrome. So I take water vapor and coke here. From water vapor and coke, I can make so-called synthesis gas. And from synthesis gas, I can synthesize ethylene. And from ethylene, I can polymerize it into polyethylene. Polyethylene is then my fourth syndrome. But if from here I want to look at properties like tensile strength, density, transparency, I'm already leaving the totality of chemical bonding and I go to the totality of macrocollectives, totality number 6. The metaphor of totality 6 then comprises all pure chemical substances, in this case like my polyethylene, additives and color agents, etc. And then I can apply in totality 6. My singulators comprise all the laws of mechanical process engineering, of fluid state, of solid state physics, of fluid dynamics, etc. And then I am already almost then I can directly go into totality pseudo 7 and make something artificial, anthropogenic from it, like plastic bags or plastic chairs or any other stuff made of plastic. And this was just the formal description of this well-known platitude that I mentioned in the beginning: the whole is more than the parts of its sum. But in scientific thinking, we often tend to forget this, because science works under the paradigm of reductionism. We think that by dissecting a thing and understanding how its parts are composed, or how its parts work together, we understand the whole. But it simply doesn't work. The parts do not contain the laws that govern the whole thing. There's something on top of that. Reductionism simply doesn't work. From time to time, you just have to introduce new laws. And every time you do that, you enter a new totality. And those laws can never be deduced from the laws that govern the elements of the totality below. Sometimes when you hear or read about this topic, you also hear the term emergence. It was conceived precisely for this topic I've been trying to explain, but I sometimes find it's kind of not so, it's kind of a contradiction in itself, because if something emerges, then it implies that something emerges from, but it doesn't emerge from anywhere. It doesn't emerge from the level below, certainly. I sometimes have the feeling that this term is more used to hide the non-reducibility in nature, rather than to bring it to light. And this term is then, well, it's kind of used to show that we have seen that there is something, but let's relay it to the philosophers and not get our hands dirty, and better not acknowledge the flaw in the paradigm itself. So Heim did not use the term anyway, but it's not entirely wrong if you use the term emergence. We just have to keep in mind, we cannot deduce the properties of water from the properties of hydrogen and oxygen. And if you take a heap of 79 protons, 79 electrons, and an according number of neutrons, you will not be able to calculate from that the resulting element will have a density of 19.3 and is very valuable. So we have new laws on each structural level. And at the same time, the laws from the higher level determine how the components on the lower levels behave. If you look at the molecule, the electron distribution of the atoms inside the molecule is completely different than that of a free atom, of a single atom. And inside an atomic nucleus, the nucleons behave completely differently, as if the particles were flying around in empty space. How stable a structure is depends on the strength of the law of the superordinate realm. It's like when the weak nuclear force is too weak, then the atomic nucleus will radioactively decay. Or if a government enacts stupid policy, then the people will do what they want and complain about the government, but not do as it was intended. The self-life of the underlying level becomes dominant in that case. So the whole of nature can be described as such a Metroplex construct. But that's not mere grey theory. In Heim theory, it's actually something real. Let us look back at his findings of the so-called hermetry forms in the video on the elementary particles. There were 4 different hermetry forms, and one of them was the so-called activities. Those were entities that purely exist in the transcendent realms, in X5 and X6, and they represent structure, and their property is to change probabilities of matter, of the material realm. And the higher the level of organization they represent, the more improbable the observed states of matter will be. And now think about what might be the most improbable state of matter that you could possibly imagine. The answer I give you in the next video, in 6 dimensions and in color.